So I hope that you've enjoyed the conference. You've gotten a lot out of it. There are things that you can take back to you at your schools. But we are not done, and I hope you have some room left for a little bit more knowledge, a little bit more inspiration from our closing keynote speaker. So it is my pleasure to introduce Michael Kolling, who will be doing our closing keynote. Michael is probably familiar to many of you, and certainly his work is, if not him individually. He is a professor at the School of Computing at the University of Kent. And my guess is most of you know him through his role as the lead developer of BlueJ and Greenfoot. And just curious, out of show of hands, how many of you have used either BlueJ or Greenfoot? I mean, that kind of says it right there on things. You may also know him from his two Java textbooks. I use his every year. And numerous papers that he's written, and some amazingly entertaining conference presentations that we've all seen. We were just talking about one of our favorites. And so he is really someone who understands us and is part of us, and that's a great thing to have him here. Last year in 2013, he won the prestigious ACM SIGSI Award for Outstanding Contribution to CS Education. So we're very lucky and very excited to have him here. He's going to talk today, give us his thoughts on computer science education, the future, tools, and whatever he wants to talk about. So join me in welcoming Michael Kolling, our speaker.
Thank you, Dave. I'll try to switch this microphone. Okay, you can hear me now, right? That show of hands there, that was just fantastic. That just made my day. I thought I can just stop now and go home, and I'm happy. That was really fantastic. For me, anyway. So now we'll see whether I can do something for you as well. Thank you, first of all, to the committee for inviting me and for having me here, and thank you all for still being here at the end of a long, interesting day when you had to listen to a lot already, and for still being here. Dave just said there will be some, I don't know what you said, information or something like that. I don't know whether it's actually whether you'll learn very much. As you can see from the title of my talk, it sounds like I'm going to predict the future. I'm being the oracle here. I don't actually know much more than anyone else, so I don't know how that's going to work. When I started writing this talk some time ago, that's what it looked like. I started to write it on my whiteboard, and I quite liked the layout on the whiteboard because I know where everything is there in the spatial thinking, and I thought first, how can I show that to you, and how can I use my whiteboard as my slides? I thought maybe I just show that and I go through that and point to this. And I thought that is too messy, and then I thought I'll transcribe it on paper, so I wrote it all down on paper again, and that's my talk. And then I thought, okay, maybe I can't really expect you to read my handwriting, so I've cleaned it up a little bit, but that's pretty much my talk. It says somewhere in the title, it suggests that I might tell you what will happen in the future. I'm not going to tell you what will happen, but I will tell you what I think should happen, or in fact, what I think should happen. So it's more of a wish list of me, what I think we should be doing, or someone should be doing, or something that I think we should, as a community, should have. I will be talking mostly about the design of educational software tools, because that's the one area that I have something to say about. I'm not usually slow in expressing opinions about things that I don't know anything about, but I'll try to stick mostly to the area that I think I probably was invited for. So that will be the theme about the design, into a bit projecting into the future what I think is missing, what we should be doing. First of all, let me start by saying, of course, when you design an educational software tool, of course you start thinking about what you want to do. You start with some design principles, you write them down, you say, okay, you want, for example, simplicity, and you want some interactivity in there, and you want something to support creativity. The particular principles might be slightly different, but you have something like that. You want to support the students, and so on. So you have your design principles, and then you start designing your system, and you end up with something. This, of course, is a complete lie. This is not how it actually works. The truth is that actually you start by some gut feeling. You had an idea one morning, and you think that somehow sounded like a good idea, and you do something, and then you build something, and then retrospectively you come up with some kind of explanation why you thought that was a good idea, and you pretend that actually you had some principle at the beginning, and you had some plan when actually it was something that came to you under the shower one day. We are not actually in really bad company doing this. This is David Parnas, one person in our field that's always good to be on the same side on. He has not only actually publicly admitted to working that way, he has written a paper about it. He has written a paper that says a rational design process, how and why to fake it. And there he says, this is, we don't have to be ashamed of this. This is actually, that's quite okay. It's still a useful way to write it down as if it happened that way. It's a useful way to describe your work because other people can still learn something from it. And a lot of people work like this. Mathematicians work like that, for example. When they develop a proof, they usually polish it for quite some time before they publish it. And the way it is published is not usually the way it was first discovered. So we polish our work a bit before we're publishing it. And so it's not really all that bad. It's just not always, very formal engineering. It's sometimes more of a craft-based discipline where you just fiddle about. And that in itself is not a bad, but there is a problem in it. And that is in the retrospective verification. If you want to do your job well, then you really have to go back and at some stage look at whether what you were doing actually did work or whether it actually, you actually did achieve what you want to achieve. And that needs a willingness to do this, and it needs the ability to be critical about your own work. And that is, I think, where we often fall short. There is too much work in our discipline where someone builds something and then you get emotionally invested. Of course, it's normal. That happens, and where this critical reflection doesn't happen. Building something just out of a gut feeling, I have nothing against it, but then we have to have actually a discipline where we go back and critically evaluate and see whether what we did actually made any sense and whether we achieved something. That is one of my points that I will come back to later today. I've said in the development, you work with gut feeling. Here in my talk today, it's the same. What I'm going to tell you about is essentially just my gut feeling. I have no evidence for anything I say. It's an opinion, and I'm just telling you up front, you shouldn't believe anything I say. I will tell you, I will pose some questions, I will put out some challenges, but there are no answers, so you have to do that yourself. Okay, let's start. My first thing that I want to talk about, just to get that out of the way, because it's an old bugbear, and it's so old that I shouldn't be talking about it anymore, but I'm still hearing this. My first point, all programming in future, from now on, that you do in your schools, that everyone does, will be done in dedicated IDEs. I'm still hearing people every now and then saying, you shouldn't be using a development environment. Use just a prompt, Unix or DOS prompt. Is that DOS even still around? Use a simple text editor, compile from the command line. That's the best for students because it's simpler, it doesn't get in the way. Don't believe it. It's rubbish. Every professional programmer and everyone who aspires to become a professional programmer or even to become a programmer who wants to be taken somewhat seriously will use dedicated professional tools. Having a plain text editor on a command line for developing complex artifacts will be like writing PostScript by hand. You just don't do that anymore. But the IDEs that we have are not necessarily now the way they will always be. There are improvements that we can make. And I just want to briefly talk about some of them, what I think we can do, and that is heavily colored by some of the ideas that we have in our group that we are working on, so I will along the way also tell you some of the things that we are working on in our group. One of the things in the presentation of programs is the display of structure in program code. I think there is a lot of opportunity for this to be improved. The display as pure text in IDEs for program representation, I think is outdated, and we have to move away from that a bit. I will come back to this point a little bit later today, but keep that in mind. We will pick that up again. The interactions of coding, that is how you actually interact with your development environment, is from a human-computer interaction point of view appalling. I think a programming system, our programming systems, must be some of the most complex bits of software that people use, with one of the worst interfaces designed to support what you want to do. Even in modern IDEs, where now the development environments get quite fancy, there's a lot of help in program entry, I think that is only a small part of the step of what is actually possible. So the analyzing program manipulation from an HCI point of view is one of the areas, I think, where there's a lot of work that needs to be done. Error messages, an old problem. We have, as a community, been talking about this for decades. There are papers from the early 80s talking about improving error messages, and it's still not happened. You still get an error message that says illegal start of expression because of who knows why. That is an area where really it is high time to do something. There's a lot of opportunity there to improve this. One of the people in my group, Devon, who sits right here in the room, is actually working in this area right now and writing his PhD about it. So if that doesn't happen anytime soon, we can all blame him. But one of the areas in IDE development that I'm particularly interested in is the question of how much should be automated in it. The point I'm getting to is the difference between environments for professional developers and environments for learners. And the question of what a development environment should do is actually quite different for those two use cases. And one of the areas in which it is different is the question of how much and what exactly the environment should do for you. There is a possibility that actually providing help does not make you any smarter. There is generally a theory in HCI that externalizing information out into the interface helps you in becoming productive. In cognitive load theory, says that reducing the extraneous load is a good thing, so that you essentially free your brain for the tasks at hand. Having information externally in the interface reduces the load on your working memory and makes you more productive. But the question here is, what does being productive or achieving performance actually mean? This assumption in our context seems to be wrong. There has been a study by Nimwing in Holland some time ago where he looked at the effects of different interface designs and different learning styles on performance in systems, and especially in learning situations. And in learning situations, the goal is not only to get some tasks done, but to actually learn something along the way. So the performance that we're looking at is actually a learning effect. And what came out of this is that externalizing information into the interface, that is providing explicit help, providing guidance along the way, yes, it does relieve working memory. That seems to be a good thing. But it actually, he found, discourages planning. It reduces the actual understanding of the principles of the task that they were doing. And the learning effect was actually reduced. That by having to internalize the information, it actually required more careful planning and had a greater learning effect. That is just one example in which the design constraints in designing an environment for education or for professional programmers is quite different. If you're a professional programmer, you just want to get the task done. If you have a learning environment, you want them to actually learn something along the way. You don't just want them to produce a slick-looking game. You want them to have learned something while doing this. So you do not always want to make it just as easy as possible getting the job done. The main point here is that we need environments that are actually designed for education. We need environments that are not just picked out, from professional developers or because they were the simplest solution. We need environments that are designed for education. There are some really good ones around. All of you know some, but there are still areas, pockets, where they are not there. Python, for example, I really do not understand why there is not a good educational IDE for Python around. Idle, what most of them. I'm not sure what the best polite way is to say this, but that's not it. And Python has lost its excuse. At the beginning, you could say, okay, it was a new language, it was just being developed, still growing, and I thought, yeah, that'll come. Python is now old enough and being used enough. It's one of the most popular languages for teaching. Python should have a good educationally designed IDE. And I really don't know why no one has written one. It's important, there should be one. So on my, let's say, wish list, the first sticker that I want to put on there is, I want to see more tools that are specifically designed for learning. The next topic I want to briefly talk about is process. That is the process that students go to when they program. I don't care only about the product, I care about the process. And often, the way it gets presented when we teach, especially in textbooks, looks like this. There's a starting point, and there's a finishing point, and you somehow move from one to the other. The starting point typically is, here's a problem, write a program that solves this problem. And then we somehow expect them to write it and finish at some stage. We have a defined finish. We tell the students, you're finished once your program does this. The way it is presented in textbooks often is as if you move more or less straight from one to the other. If you pick up a textbook, often it presents a problem, then it presents the solution to the problem, a program, and then explains the program and explains how it works. And says, this is this, and here's some new constructs that we haven't seen before, and explains how these work. That creates the illusion in students' minds that a good programmer should be able to move from here to here in one straight line. Of course, that also is a lie. What actually happens is something more like this, especially for students, but not only for students. Every programmer, we know that we do something, and then at some stage, we discover that wasn't actually so good, and we change it a bit, we take that back, or we have a method that we thought, it actually is too long, and we break it out in two methods, or we join it again, or we move that. We go back and forth a bit, and we stumble our way to the solution. With students, first of all, we never talk with them about this, and we actually don't know what they're doing. We don't even look what they're doing. We just say, here's your problem, hand it in 2 weeks, and then I look at your product. If they do this, that is actually the lucky case, because in this case, actually, it arrives at the finish. Actually, more often it is something like this, or sometimes something like this. And in fact, so this, getting from the start to finish, we have no idea what happens in the middle. We don't know what they're doing, and we're certainly not giving them any help with it. So I want something that reveals the student's process, where I can see what they're doing, and that helps us to guide them in their process. And giving feedback along the way is important as well. So the next thing on my wish list is tools to support the process of programming, where we can actually see and influence the actual way of programming. And while I'm talking about process, I have another aside, process for a community. If we talk about us as the computer science education research community, that is all those of us who do education research or CS education research, what we're actually seeing here in our output, that is mostly papers that we produce, there is a lot of practice, there's a little bit of theory, and then there's very little evidence. That is pretty much sort of what it looks like by volume, and I think that has to change as well. We need more evidence for what we're doing. One of the projects that we are currently doing that tries to help a little bit with this is connected to BlueJ. In BlueJ, in the latest version, we have now another system connected to it that is called Blackbox. Blackbox is a system to collect user data from users of BlueJ. It's an opt-in system. If you run the latest version of BlueJ, you will get a dialog when you start it up, and you are asked whether you would like to participate in anonymous collection of data for research purposes, and you have to explicitly click OK and opt in. That has been running since last year, and the opt-in rate is actually surprisingly good. We have about 40% of our users who opt in, which is much higher than what I expected. We have been collecting data since then. At the moment, over 300,000 users are already in the database that we have collected data from. There are over 1 million projects. There are a lot of compilations. We are getting about 11 interaction events per second coming in. So since since I started talking here, there are another 10,000 or so interaction events that we have recorded from several hundred students. That is a basis, a repository of data that now we can start to do some research on. That is research that we do not only want to do ourselves, we are quite happy to share that data and make it available to other groups to have some more fundamental research about computing education topics. That does not solve the problem that I said at the beginning that we need more evidence, because that is just a pile of data. That is not actually research work, but that is our attempt, since we thought we have the users, we can actually produce some data, how we want to try to encourage the community as a whole to do a bit more data-driven research. Going back to what I said before, I talked before about error messages. Now when I talk about evidence and more, a bit more evidence-based research, about error messages, I actually saw at a conference a few weeks ago at the ITXE conference an interesting paper with this title, Enhancing Syntax Error Messages Appears Ineffectual. A few people from New Zealand actually did a study, and they tried exactly this. They tried to improve error messages and improve student performance through better error messages, and they did a lot of work putting it in to improve the error messages in their system. And at the end, the result was, it makes absolutely no difference. They actually did a fairly detailed study. They had a control group. They looked at the performance. They had wonderfully elaborate error messages with examples saying, this is what you're doing, this is what you should be doing, here's how it's right. And at the end, no difference. And that is a good thing in a way, because for our discipline, reporting negative results when things don't go well is important. And I was actually very happy to see that someone was doing that and reporting something that actually didn't work. And then again, for Devon's sake, who's working on improving error messages, I hope they are wrong. Okay, community process. That is something else that I put on my wish list. I think as an education research community, we need a bit more scientific process, a bit less hand-waving, a bit less sort of wishful thinking. Another area I want to talk about, because that is another topic that comes up regularly over the last few years in our field, is what the abstraction levels should be that we start at in teaching. And that is very closely related to the famous question of, should you start with objects or not? Objects first, or procedural first, or where do we start? How high in sort of the levels of abstraction can you start teaching? Do you have to understand pointer arithmetic to be a programmer? Do you have to be able to write assembler code to be a programmer? Often now when you talk to people, they say, well, you really have to understand, procedural programming, otherwise you're not a proper programmer. Just a few years ago, it was essentially people said, oh, you have to understand pointer arithmetic. If you don't understand memory management, you will never understand programming properly. And 10 years before that, they said, you have to understand assembly language programming, otherwise you will never be a real programmer. What it typically is, I think, so this is how I see things. Our discipline is essentially levels of abstraction. And I don't care now what the labels are. It starts, somewhere application programs are at the top, And here is whatever programming paradigm you're using, object orientation or functional or something, and there's the machine code underneath, and there's the operating system underneath, and there's hardware underneath, and there's a processor, and in the processor there's electronics, and underneath is physics, and you end up with quantum mechanics or so at the bottom. And we don't understand it all. No one here in this room, if you stand up and say, I understand that all, you are lying. There's not only can no one properly explain quantum physics, but can you explain how your processor works? No, you can't. If you think you can, you are deluded. How many pipelines does your processor have? The answer is you don't know because it's a trade secret. They don't tell you. You can you can explain a von Neumann architecture, but that's an abstract model. That is not how it really is. And so when people come up and say, well, you have to tell them how it really works, there is no how it really works in any sense that you can actually explain. So what everyone does is you draw a line somewhere, and you say, well, everything underneath is sort of black boxes. You don't need to understand the details. It's just there, and you know it's there, and you just trust that it works. I know I have a processor, and I know I have memory, and I just trust that they work, and I don't care how they work. So there is my line. Where you draw this line is the question. Everyone has that line where everything over that line you understand, everything underneath you don't. The question only is, where is that line? You cannot have a discussion about whether you have a line or not. You do have a line. So the question is, where can you draw it? Typically, when we teach, we teach somewhere up here, we start somewhere, and then you work down from there by analyzing it, and you work up from there by building something up. You start, and it is the question about what is the required knowledge to be a computer scientist, and what are the acceptable black boxes. Now, the way people answer this question reminds me of another theory. Ontogeny recapitulates phylogeny. That is also known as recapitulation theory. It's an old theory. It comes from biology. It was developed by Ernst Haeckel. He was a German philosopher and scientist in the 19th and early 20th century. And he had this theory. Ontology is, the theory says that individual organisms in their development from embryo to an adult undergo the same development as the species as a whole did in evolutionary processes. So when the species went through, this somewhere from creeping out of the water onto land, growing legs to something else at the end, that the embryo in its own individual development undergoes the same processes during its development. That theory, by the way, don't memorize it too closely because it's been proven wrong. It's not true, but it was popular for a while. And this is what it reminds me of, because I think that is what many teachers are doing who argue this point. Essentially, the argument often goes, I learned it this way, and I arrived at this point, I understand it, so you should do the same. You should undergo essentially the same process how I learned. I started learning with C, so that is obviously a good thing. The definition of what you need to know and what you don't need to know, essentially, if you look at it closely enough, boils down to everything I know is obviously important, everything I don't know is obviously not important. It's the, it didn't do me any harm argument. So, I learned assembly language programming, so should you. It's good for your soul. That argument is, it's probably the most common approach to deciding what your students should learn. You teach them what you learned. And, I don't want to criticize it too much, but that is not a defendable argument in the big picture. What we actually need, I think, is a notional machine. A notional machine is an agreed abstraction level between all of us where we say we have a definition of a theoretical computer. A notional machine is a conceptual abstraction. It is a conceptual computer that is well-defined enough, low-level enough that we can explain all observable behavior of our programs, but abstracts from all the details that are relevant to our discussion at the hand. And I think we need that to have a better discussion about how programming works. At the moment, we are working on that in BlueJ. Here is a prototype that one of my PhD students is working on. It's another new interface that would be the main interface of BlueJ if we ever release this, where now the object bench in BlueJ has taken up most of the screen, and you can actually see when this runs all the objects coming into existence and being created and being deleted. And when this runs, if you make a method call, by the way, just as the speaker this morning, I also have a low quality video, but I don't have any excuse of it being 20 years old. It's just a bit not very smooth in running, but this is essentially when you invoke a method, it shows you the execution of the method. It shows return types here being passed back. You can see what's going on. When objects are being created, you can see the objects appearing. When they are being destroyed, you can see them disappearing. And you see the methods that are being executed. You see the call chain, and you see the state of the object. So you can see here the fields in the object. And that is an attempt to define a notional machine. That is, we defined an abstraction level. We defined a visual notation to go with that abstraction level that can be used to reason and to talk about program execution. And so this is our first attempt at doing something like this. And you see that, for example, what is typically the stack that shows is integrated into this diagram. So it is one language, one visual notation that expresses this notional machine. So I put that on my wish list. I don't think that our solution will be the final say in that area, but I think as a community, that is a worthwhile thing to have, not only to have as a software tool, but to have it as a notation that we can use on whiteboards and in talking to each other. I want to say a few words about simplicity. Simplicity is really important in software tools. We all want tools to be easy to use. Intuitive is often thrown around. Personally, I don't like the term intuitive. There's nothing. Intuitive just means you've seen it before. But we want our tools to be simple to use. Simplicity is one of the overarching principles in design of educational software, or indeed of any software. But the first question is, what does that even mean? Simplicity can mean many different things. It is hard to achieve, that we know. Producing tools in complex problem domains that are simple to use is not easy, but we still don't know what it actually means. The problem with simplicity is that it can mean different things. There is simplicity for professional programmers, and there's simplicity for learners, and they are not the same thing. In fact, they are pretty much direct opposites. When I talk about simplicity, I'm talking about both programming environments and other tools and programming languages. We want simple programming languages. That is why Java is falling more and more out of favor, because it is getting actually less and less simple. With every new release, it is becoming more complex. It is moving further and further away from what we actually want. But when you talk to the designers of Java, to the people who actually do make the changes, they say they're doing all this to make the language simpler. And in fact, they are. But they are making it simpler for the professional programmers. For professional programmers, to make it, when they say they want simplicity, they mean they want, for every problem that they may want to address, a set of language constructs that allows them to express this problem in an elegant and simple way. And to do this, they want more language constructs. They want different, partially redundant and overlapping language constructs, because for one particular problem, this one particular construct maybe allows me to express it more simply. For learners, you want fewer features. When we talk about simplicity for learners, we want a language that is not redundant, that has one simple way to do any one task, and not three different ways to achieve the same thing that only differ in maybe the number of lines of code that I need to express it. So simplicity is not a universal concept that we can just throw around and assume that everyone knows what that means. Simplicity for our tools, for BlueJ and for Greenfoot, has always been one of the highest principles in our design. So we actually do have some principles that we use that we made up after it was released, but still we have them. Simplicity is one of them. One of my favorite quotes is by Antoine de Saint-Exupéry, and he said, "Perfection is achieved not when there's nothing more to add, but when there's nothing more to take away." But then there's also the famous Einstein quote where it says, you know, make it as simple as possible, but not simpler. My role in guiding the design of BlueJ and Greenfoot over the last few years has more and more become saying no to people. We get a lot of ideas and a lot of suggestions of what to put in, new features to put into BlueJ or new APIs to put into Greenfoot, and many of them are nice ideas, they're good ideas. Taken individually, they are actually very reasonable, but if I take them all together, they would completely ruin the system. It just gets too big and too complex. So having to say no to people, I think that is one of my most important jobs, and that has become my guideline here in doing this. You can go too far, though. There are some environments, and I don't want to mention idle again, but think in that direction, where just there is not enough there. Simple does not mean just to have almost nothing on the screen. You can still support a learning process and experimentation and you know, trying things out, exploration. There are tools that are actually helpful. Having nothing there is not simplicity. It's not as simple as counting the number of user interface elements on screen and thinking the lower the number is, the simpler your environment is. That's not it. It is actually more to do with how hard it is to achieve certain tasks and to find out, to learn how to achieve them. So Java, in that sense, is a problem. Java is actually getting more and more complex. It's getting more and more redundant. It is still a nice language to use if you're a professional. For teaching, it still works, but it's not as nice anymore as it used to be. And the problem is that what I think the designers of Java don't understand, I have talked to them actually while they were in the process of designing new language features, and they always say, look, it's quite simple to understand. You know, this is how it works. It's not all that hard. You know? The problem is for them, they already understand everything that's there. And then just this one more feature, well, that's not so hard. But that's if you're here already, then this other step. If you are here, you know, right at the beginning, then having all these extra steps that they have added over the last years adds in total quite a lot. And the problem with Java also is that every time they have a new feature, typically it does not replace the old feature in the sense that you don't have to explain it anymore. For example, once they introduced autoboxing, you still have to explain wrapper classes because you can't actually understand autoboxing properly without knowing what is actually internally going on. So you don't replace one construct in your teaching with another, you have to explain both. And even though for a competent programmer, it's a nice feature to have that makes your life simpler, for a teacher, it is more. It is more complicated. So the reason why I like Java is because it came around at the right time for me. I grew with the language. The language, for me, it was reasonably easy to understand because when I started learning it, the language actually was fairly simple. And then, you know, I had the opportunity to learn every new bit, you know, year by year, slowly as it came out, and then it is okay. But if you're confronted with a language like that now as a learner, as a beginner, it is fairly big. So it seems to me at some stage that every generation maybe needs their own language. That every now and then we just need a new one because you cannot stop a language from growing. You cannot, if you try to make the counter argument that Java should have not been changed, that is not going to work. Languages, like any software system, do not just persist. They either develop or they die. There is nothing in between. They grow or they die. There is no status quo in software. And that's not the fault of the language designers. That is in the nature of things. The same will happen to Python. Python at the moment is still a little bit simpler. That will change. And that's just in the natural, in the nature of our discipline. New ideas, new concepts, new things will come around the corner that we want in a language, and if you have to retrospectively bolt them on, it is always more complex than starting from scratch at that point. So I think what I would like to put on my wish list is a new language. I think the time is right to have a new educational language. And Python is not it, unfortunately. It's maybe the least worst thing that we have at the moment, so it's not a bad choice if you're teaching, as Java also is not a bad choice. But neither of them is ideal. I think we can do better. I have talked about a few things that I want to come back to now. I have mentioned structure display before as one of the elements where we can improve things without explaining it very well so far. I have talked about coding interactions, I have talked about errors, and I have talked about a new programming language. And I want to talk a little bit more about what I mean by that, because that's an area that I only briefly mentioned without explaining it properly. At the moment, what we are having is we have some languages in education that are block-based, something like Scratch or that whole family of languages, Star, Logo, Alice, all the graphical block-based languages. And they work very well. Especially Scratch, I think, is a fantastic system. The problem with that is that sometimes I think they're getting used too long. They work so well that people are reluctant to leave them when they actually should be moving on. And then the next thing, we have text-based systems where we write code that looks like this in text-based programming systems, and that is where we want to end up. At least those people who actually go into computing or software profession, they should eventually be able to do something like this. That is where we want to get to after some time. But the question still is, how do you get there from one to the other? It's actually quite a large step. There is a space in between where I think there is an opportunity to do something and improve things in quite a fundamental way. You can think about it like this. We can make a diagram. We have two axes here. In one axis, we can look at the input opportunities. So we can either have mouse input or textual input. And on the other axis, I put the presentation, how the program is presented. We can do that in text or graphically. So we have 4 quadrants, and in those quadrants, systems like Scratch are here. It's a graphical representation, and you manipulate it mostly with a mouse. And then programs like Greenfoot are up here, Alice and App Inventor, and those systems are all down there. They are mouse-based graphical, and the other systems, Eclipse and NetBeans and so on, all up here. They're keyboard-driven, text-based. And then you see that everything happens on this one diagonal here. And the question is, what's happening in the other 2 quadrants? That one up here would be something where the presentation is text-based, but you work at it with a mouse. Doesn't sound so exciting. You could come up with some examples how you could have that. It's a bit contrived. I don't think that's very interesting. But down here, I think there is an interesting space. So what about systems where you have a more graphical representation of your program, but you don't have to use the mouse the whole time, where you can actually work with your keyboard? Because when you look at more practiced programmers, they actually like to work with their keyboard. It's actually not a bad thing. And text as a presentation, as a representation of a program, is actually working very well. Having a program represented by text does work well. But systems like Scratch have distinct advantages. Much easier to use, much easier to learn. They avoid many, many errors. But still, if I wrote a program now for a significant problem, I would not use Scratch. Why not? Well, it's just too clumsy. The language isn't powerful enough. Once you outgrow it at some stage, not only in the expressive power, but also in the programming interactions. This dragging with a mouse, especially then when you want to make changes, where you have to drag things out and then you have to drag it is just too cumbersome after a while. It is great for beginners, but you outgrow it at some stage. At some stage, if you teach 15 and 16-year-olds and they're using Scratch, they do get impatient after a while when their ambition outgrow the ability of the system, and then is the point when you want to move them out. And I think there is something a bit better than just going straight into Eclipse or NetBeans. There is a possibility where you can get something that lives in the middle between those block-based languages and the traditional text-based languages. We are working on a system like this at the moment, and Neil Brown is sitting there, works with me, is one of the people who does most of the work on the system at the moment. So if you have questions afterwards, you can talk to him as well. We are working on a system that is trying to get the best of both worlds. We're looking at what do we actually like about text-based programming, what do we like about Scratch, and we're trying to we ask the question, can we develop a system that gets the best out of both? We are currently building that into Greenfoot, and I will show you a quick demo. And now my age shows I need my reading glasses. And I need to, where's my, I'll mirror this here so that This is a development version of Greenfoot, and I show you a little bit what it looks like at the moment to give you an idea. So what I'm talking about at the moment is just the editor. So we are, in effect, designing a new language, but we are not actually interested so much in programming language design. We are much more interested in looking at the interactions of program entry and program manipulation. So here is a class, and if I am in the method, I can now hit a single key and I get an assignment statement. And I can put something in there, and I can, if I hit another key, if I want an if statement, I hit just a single key and I get an if statement. And I can type something in here, and then I can say, have a method call where type something in. So the principle here, so first of all, what you see is the display is slightly different than in traditional text-based programming environments, in that, for example, for scope, to display scope, we display that as a graphically drawn box rather than with brackets. Text, using ASCII characters to represent programs is obviously not always the best way to represent things. The fact that we're doing that is an overhang from 50 years ago, because on TTY terminals, that was the only thing we had, and that was your only choice. But once you start thinking about the ability to have half a statement in your program, to have an if statement where the closing bracket is missing, that is the most common problems of beginning programmers in Greenfoot. By far the most common problem every time is that they're getting the brackets out of whack. They have a bracket too many or not enough closing brackets, and they don't see it. The fact that you can even have half a statement is stupid. It makes no sense. Why? Scratch has shown us that it's not necessary. You either drag your if statement in there or you don't. You never drag half an if statement in there. And the fact that you do it by dragging, that's incidental. We can also do that with a keyboard. So we have borrowed this idea. We are doing the same thing as well, just keyboard driven. But when you enter an if statement, you get an if statement. You don't get half an if statement. You cannot just delete the closing bracket. Of course, there are some elements in it, like the condition and the body, where you have to fill something in. But the if statement is either there or it's not. So if I do something here now and I do a while loop, for example, and then I can, that's all. Don't try to figure out what that means. I'm not writing anything sensible here. This is just an example. So those of you who have seen Greenfoot or BlueJ in latest versions, it will look somewhat familiar because we have done some of this display in those systems already. But in Greenfoot and BlueJ currently, it is only decoration. It is only a display. You can see those scope highlighting, but you can't do anything with it. In the new system, now you can manipulate it. So if I have a while statement here, I can take it and I can put it somewhere else. And I can take this statement up and move it here. So the difference here is that editing is not at a character level, it is at a statement level. You do not insert and delete characters as you do in almost every other text-based system. You insert or delete or manipulate statements. And that fundamentally changes how you interact with the system. You can do a lot of things. So if you have a class that is a bit longer here, for example, it makes the manipulation a lot easier. First of all, it avoids many syntax errors. So many of the most common syntax errors in Java, you just can't make anymore. It shows, it makes manipulation easier by being able to drag logical units around rather than characters. We can also improve display. For example, if you scroll up now, once you scroll the header of the methods out of the way, the method header here in the editor now sticks to the top of your screen so that you actually know which method you're in. Because once you think about it, if you're running out of screen space, being able to see one more line of code gives you very little, but knowing which method you're in is actually useful. I mean, that is just one little detail how, once you start to think about programming in HCI terms, is, what is actually the useful information that we want to have on screen? You can come up with a long list of things that just has not been done. Programming, representation, and entry is a fairly unexplored wasteland in the HCI terms. Another detail, for example, if you scroll up here, once the condition of the if statement goes out of view, it tells you here at the side which if statement you're looking for. So we write the condition at the side here so that you know where you are. There are a whole number of things that you can be doing that... No, I have to... Where's my doc gone? Half of screen, where's my Keynote? So, that is one of the areas where I think there is a lot of space to improve environments. And it's not only for educational environments, by the way. I think this method of interacting with program entry will be in all systems at some stage. At some stage, we will look back at entering single characters when you want to write a program as a crazy idea. It is not necessary. So that is a bit more advanced than the notional machine that I was talking about. That is something that we are very seriously working on, and that will make it into Greenfoot at some stage in the near future. So what I have had on my wish list so far is I said I want some tools designed to support learning specifically, not just program development. I want some tools to support the process of development. I have said I want to see an improved process for us as a community. A notional machine is something we should be looking at. I think we should have a new language. And what I find most exciting at the moment, a new interaction style for program manipulation. That is my wish list. And with this, I'm running out of time, and I end here. So that is all I have to say. Thank you very much.
Thought I was third. I'm actually first. Okay. Thank you again for an inspiring speech. Wonderful. I've seen some arguments early that the blend actually is along that pathway. I love what you're doing with this new interaction style. I think it's dynamic. What do you think of an idea that connects that perhaps is the way you interact in the future with the top right? Right? So that's the top right. That's the new top right. The bottom left is a block-based style that allows you to flip it at any stage and go to that model. So if you're kind of tired of that interaction style, you say, I want to be able to type it faster than click, but it's still the same semantics, it's still the same system, same sprites, same animation features, all the same thing. You're just flipping in a way that gives you the chance to kind of be faster than dragging, because I agree, I'm a block-based person myself, and it's slow. And so we're trying to work on ways to make it faster for those who want to stay for a while, a little longer than maybe they need to be able to be faster, but still make use of those features that they like in that. What do you think about that style to be able to kind of flip the model but stay in the same paradigm in that sense?
Yes, I agree. I think that is a good thing, and that is right. And one of your other points you made in passing is also right. I think that what we are doing here, I said it may eventually replace all traditional text-based programming. It will not replace the block-based programming. I think the block-based, mouse-based drag-and-drop programming as an entry level for 8-year-olds is an excellent thing, and that will stay, and we're not improving on that. We're not replacing that. That will always be there, and it will always be first. And it has additional advantages that we're not achieving. For example, the ability to see all the blocks that you have available. And so that is the thing. Flipping that to the other side, we have talked about that and thought about this in our group as well. In the system that we are designing, you will be able to flip between our representation and pure Java, and you can flip back and forth. And you could do something like that between a block-based language and a text-based language. That is possible, and that may be helpful, and in a learning process at some stage that may be a good thing. You have to think about that a bit carefully, because typically these two representations that you're seeing, then they are two different languages. The text-based languages typically makes only sense if it is an existing language. You probably don't want to invent yet another language. If it is an existing one, the expressiveness might be different. For example, in Java, we can express things that we will not be able to express in our language, in our representation. So it is a sort of a one-way thing. We can show our representation in Java, but we cannot show every Java program in our representation. So as a viewing thing for flipping back and forth, it works. But as soon as you start editing on the Java side, we cannot guarantee anymore that we can go back. And so you have to have some answer in this. So there's some little technical problems, but in principle, yes, I perfectly agree that is a very good idea. Any other questions? Then I thank you for listening. And